Hello, my name is Damien Dusha. I'm a software engineer with the Leica Machine Control Division here in Brisbane. So about the innovation in the GS18, how did it actually get started? It actually started out with the requirements for one of our products in that tilt compensation of a pole has long been the holy grail of the surveying pole. Because once you get tilt compensation, it opens up a whole range of applications that you couldn't do before. You can do hidden point, you can do measurement up against walls, you can stand behind barriers and take points. It really opens up a whole different workflow compared to the standard perfectly level, perfectly vertical antenna. So based on the ideas that we had, we were able to go ahead and build a prototype. We based the prototype on the GS18 T. We built an add-on box, an add-on IMU. And the whole key to the process is not the IMU alone. It's not the GNSS alone, it's how they interact. And how they interact is absolutely crucial as to how we do the sensor fusion in the GS18 T. So with the prototype that we developed, we did some videos, sent it to Geomatics, and they said, well, okay, all right, we need to see this, come and do a demo. Everyone liked it, and when it came to kick off the GS18 T project, I was actually invited back to Hilbrook to hand over the knowledge and the expertise that we developed here in Brisbane so they could integrate it into the next generation product. So they've done a fantastic job of it, but it sounds easy, it's harder than it looks. So we had this idea, the idea derives from the aerospace industry. It's something that the aerospace industry has actually done for a long time. So GPS and IMU sensor fusion has been done on things like fighter jets and commercial airliners for probably 20 years. Catch is, the aerospace does it in a very particular way. So we've got a few little challenges translating this idea from the aerospace domain down to something that surveyors can actually use. We borrowed some technology from satellite navigation, we borrowed some technology from robotics, we invented some new stuff as well, and eventually, after some trial and error, some integration, we managed to get something that both A, worked, and B, most importantly, something that could be implemented now into a product and not something that we had to wait 20 years for computing to catch up. So what sets the GS18 T apart from everything else in the market? Really, there's two things. First is the complete lack of magnetic disturbances. It's something that can be relied on every day, each day, from every surveyor working on site without having to worry about the environment that is around them. The second main feature of the GS18 T, and this is really worth emphasizing, is that we continually cross-check the GNSS measurements and the IMU measurements every single time a measurement comes in. We've put an enormous amount of effort into making sure that the coordinate quality that you get out of the tilt compensated is every bit as trustworthy as the coordinate quality that you get out of a traditional GPS instrument. And that's something that competitor solutions can't get close to matching. The interesting thing about the tilt compensation feature, it's not just speeding up the workflow, it's making life safer for the surveyor as well. So for example, if there's a point on the road that needs to get measured, if it's close enough to the footpath, the surveyor no longer needs to step on the road. They no longer need to block off traffic. They no need to get in traffic control. They no need to expose themselves to traffic. They can directly measure that point from the footpath without having to enter the dangerous environment. When we talk about calibration free, it's more the point of we do the calibration so you don't have to. There are two real components to this. Firstly, we do a pretty extensive factory calibration. It's done with really typical Swiss precision. They've put a lot of time and a lot of effort into making sure that that calibration is true, correct, and accurate. The second part of the calibration process is that we actually do continual self-calibration of the sensor. So in the process of constantly cross-checking the measurements that we get from the GPS and the IMU, we actually do a small amount of self-calibration on the fly. That way we can take into account errors that creep in due to aging of the sensors or any sort of imperfections or any sort of measurement errors that we would otherwise get by being exposed to a different environment. So that's why you don't have to go back for annual calibration, you don't have to go back to get the instrument recertified every year. So what is the contribution of this to the economy? We can start with faster surveying. So a surveyor can go out and spend probably an hour less a day out in the field. That speeds up the surveying process, which will speed up the construction process, which speeds up the as-built measurement, which speeds up the entire project. It means that we can get done more, faster, in a more cost-effective manner than we've previously been able to do before. It also has some more subtle benefits as well. By making sure that the pole doesn't have to be level, there's less potential for mismeasurement. It means that there's going to be less rework. Less rework, faster projects, less cost on projects. We can talk about safety. That also contributes to cost savings in construction projects and contributes to the economy. It means that surveyors are no longer exposed to unsafe environments. Simply put, convenience and safety. So surveyors and construction workers, it really makes their life easier. Not only is their work faster, not only is their work safer, but they're able to enhance their situational awareness because they no longer have to have this laser-like focus on the bubble. It means they can concentrate on their surroundings, they can see what's happening around them, they can see if there's cars moving on or off site, they can see when there's dangerous situations happening before it actually comes and affects them. So how does the GS18 T represent world's best practice? It's not so much world's best practice, it's a world first. Silicon Valley startups out of Stanford and MIT, they love talking about advanced sensor fusion. Here at Leica, we deliver it. We don't talk about it, we deliver it. Sensor fusion is no longer something that is the rarefied domain of the aerospace industry. It's now something that is here and now for thousands of surveyors and thousands of the construction workers around the world. It's validation that Australian engineering and Australian innovation not just matches the rest of the world, but can actually exceed it.